6.1b, we are continuing with our law of sines, but we are talking about specifically today the side angle in terms of law of sines. So if you're given two sides and a corresponding angle from one of those sides, then we can determine what the third side is. But there are also some rules to it. So in this scenario, we are given, let's call the sides A and B, and the corresponding angle that we are given, let's call that corresponding angle A. There are some rules with how many answers you can get with the third side C. So here we want to find side C. That is the side that is not given. We don't know what that is, but we can determine how many answers can side C have dependent on certain factors. First factor, what we want to consider is we want to first think about our H. Our H is our altitude, but H doesn't cut angle A. So H goes between side A and side B, and this will be our altitude here. And remember, an altitude is from one vertex to the base, and it makes a right angle, and we'll call this H. And to get H, we use the formula H equals B times sine of A. And let me show you why that is. If I drew this, the right triangle H, that portion right there, imagine this is H, and this is angle A right here. I'm going to rewrite everything. And this is B, and that's all that we have. So we know for sure already, we know that the sine of A has to equal H over B. Well, then H then also has to equal B times sine of A when we move things around. So that is the first value we have to consider. We find our H, and now we also have to consider our value B. And our B is the value that is adjacent to angle A. So if somehow we find that our H, so we find H, and A is in between, the distance of A is greater than the distance of H, but it's also less than the value of B, then there are two possible answers. There are two possible triangles that can be created from these distances. However, if we find that we find A, the distance A, is just less than or equal to B, if it's just less than equal to B, and it's also less than H, if A is less than H, right? A is less than equal to B, or A is just less than H, both ways, then there are 0 possible triangles that can be created with this. But then if you find that A is greater than or equal to H, or A is greater than or equal to B, or A is greater than B whatsoever, as long as it's greater than these values, then there is only one possible other length of the other side. So there's only one triangle that can be created using those dimensions. Let's do some example. I know I can give you what the theory is, but let's do some example. So let's say they gave us angle A is 110 degrees. A itself is, the distance is 185, and B is 260. So let's figure this one out. First, I already know that A is less than B. So from my check mark, this isn't looking good. A is less than B. So here, it could either be this or this. If it is less than H, I'm going to find H now. And if it's less than H, then there are 0 possible answers. So I'm going to check that H, once again, is B times sine of A, which is 260 times sine of A, which is 110 degrees. So let me erase this A here. It's 110 degrees. I plug that into my calculator, and I get 244. 244, A is then less than H. So it's less than B is less than H. It is impossible to get a triangle with these number combinations because A cannot be less than both B and H. Let's try a different one. Let's say we are given the value A equals 20 degrees, 15 minutes. The distance of A is 9.5 and B is 22. First things first, we want to check our parameters. Do we have two? First, I'm going to check if we have 2 answers or 1 answer or 0 answers. So first things first, I'm going to convert this A into a decimal just because it's going to be easier. So 20 degrees, 15 minutes, punch that into my calculator. I get, this is 20.25 degrees. My A is already less than B, so I either have 0 answers or 2 answers. So let me check my H. My H is B times sine of A, so 22 times sine of 20.25, which gives me 7.615. So A in this case is greater than H. A is greater than H and less than B, so it's in between. This means I have 2 answers. I have 2 answers, so I got to find both possible answers. So let's think about this. So first we want to find out, what does that mean? What angles am I working with? So let's draw a picture of what we have here. We have here angle A. Angle A is 20.25. So this is 20.25. We have the side A is 9.5. And this is B. B is, I'll call this A, B, and C. B itself is 22. I can find out what angle B is then using my sine theory. So here, I know that 22 over sine of B must equal 9.5 over sine of 20.25. That gives me sine of B should equal 22 times sine of 20.25 divided by 9.5. And then to find the actual angle, I'm going to take the inverse, right? The inverse of sine of B. Once I punch that into the calculator, and it should give me my angle. My angle B then, I find, is 53.28 degrees. So my angle B is 53.28 degrees. I'm going to go back into my picture, and this is 53.28 degrees. So let me find out what the third angle could be, because there's 2 angles that could create this. The first one, of course, I got to do 180, find out what my angle is, minus 53.28 minus 20.25. That gives me 106.47. So angle C is 106.47. So now I got to find the two different values of B. B in our case, since there's two triangles, B can be two different values. So we found A, B, and C. The other value of B, we just take 180. We just take 180 minus whatever we already have, 53.28. And that will give us the other value of B, which will be our larger B, which is 126.72. So this is the second value in which B can be. So let me draw that triangle and what we have with that one. If I draw that triangle here, and let me try to replicate the first triangle a little bit. We got A, B, and C. And I have this one being 126.72. A will always be the same. This is 20.25. Let's find out what the other C value has to be. We take 180 minus 126.72 minus 20.25. That gives me my smaller C value as 33.03. I have the exact same value, so now I want to find what the third C value, this side C, needs to be. To do that, I've already been given A and B. B is for sure 22 and A is 9.5. Those are our givens. So I can use any one of these. So I can say 22 over sine of 126.72 must equal C over the sine of 33.03. That gives me C should equal 22 times sine of 33.03 all over sine of 126.72. Just punch that into the calculator and I get C should equal 14.96. So this is 14.96. Let's do one last example. So let's say we are given B equals 54 degrees 30 minutes and A equals 64 distance and C equals 35. And I want to find the area of my triangle. And remember, our area is not just 1/2 length times height. So if I put in values A, B, C, so let's say this is, we'll call this A, B, and I just find it's easiest to just fill in what we have. 54 degrees 30 minutes is the same thing as saying 54.5 degrees. If you put that into your calculator, A is 64, C is 35. So here we have an angle, and using that angle, if I draw an altitude like this, I can easily find this height right here. Isn't my area 1/2 base times height? So it's 1/2. We have a base, which is 64. My height, remember, is my sine of my angle times the hypotenuse, which is 35, or in this case 35 sine of 54.5. So here my height is 35 sine of 54.5 degrees. If I put that all into my calculator, I should get the area is about 911.8.